let's put it all into practice, finding the area of a regular polygon. And let's say it's an octagon with 8 sides. So n number of sides is 8. And let's say we're told that a side length is 10. So our jobs are, first, we're going to find this little angle theta. And we find that by doing 360 divided by the number of sides, which is 8. That gives us 45. But the 45, that's this angle. We need half of that. So we divide again by 2, and we get that the little angle is 22.5. All right. Now, what we have is essentially a little right triangle where we know that we've got an angle that is 22.5, and we've got an opposite side x, which is 5, because that's half of the actual side length of 10. And we want to find A, the apothem of the polygon. So that is opposite and adjacent. We are going to use tangent, because tangent is opposite over adjacent, if you remember your SOHCAHTOA. So we'll take the tangent of 22.5 degrees, and that will be equal to opposite over adjacent. And doing a little simple algebra to solve there, we multiply both sides by a to get a out of the denominator, and then divide both sides by the tangent of 22.5. We find that a is going to be 5 over the tangent of 22.5. And plugging that into a calculator, we find that that is 12.0711. I'm keeping all of the decimal figures my calculator gives me. In fact, you should just use the answer key on your calculator to keep all the decimal accuracy until the end, and then round at the very end, because otherwise you might get a rounding error, which a fussy online program might say, nope, you're wrong. It's not 22.3, it's 22.2. So we'll keep all of our accuracy through to the end. Okay, we now, in our inner triangle, our gold triangle here, we've got the height of the triangle. That is the 12.0711. And we've got the base of the triangle. That's this side length 10. So we're ready to find the area of the triangle. And that's just 1/2 times base times height. And plugging that all in, that's about 60.3553. That's the area of one of the triangles in here, but there are 8 of them in this octagon. If it was a hexagon, there'd be 6, and so on. Anyway, we are going to take our previous answer and multiply by the number of sides. We get 482.843, and we now round that to whatever decimal accuracy was asked for. Let's say 1 decimal place, and there would be our answer.